Yeah, so let's start from yeah. So we have seen that we have output and the hidden layer. After doing the first iteration, the I is 0, and if we have the output console, we just again one small pc output dot shape is 119 and the hidden dot shape is 128. Now the interesting things is, so first we created this if we see, this is the execution graph for output. So let's say if we do the back propagation, that's how it will back propagate, and this is for the hidden. So the only difference is we have a softmax function here, and here it's we don't have a softmax function. It's a add multiply matrix multiplication, and then this is transpose backward. This is log softmax addition matrix multiplication and for the bias, and this is for the weight matrix. Here we have to further do transpose backward. So let's go further, and if we go into one more step, so what's happening now is an interesting thing. The hidden layer is the one which we got from the back, and let's go further into this. So what it's doing is, again it's doing the same thing. It's combining it. It's combining the input, which is now the input is, if I see what is my input, so my input was, I think this is R, A B C D E F G H I J K L M N O O. Okay, yeah, so let's go. So this is coming to O. We'll see what the word is. Yes, we have, because we have restarted this. So let's go over again. What it will do is, it will combine, it will do the matrix, multiplication, linear transformation of this new matrix, which is input plus the old hidden layer, and we'll get a new hidden layer. Same for the output. Again we are doing the same thing. If we see that it says it is same like the hidden, right now it's not combined in a way, but we'll see what we do, why we are doing this. So we are doing the softmax again, return output, and if we see, so my line tensor, if we see here, category tensor and the line tensor, and what is my line, so let's see what has now after step 1. Now this is interesting. So what has happened after step 1 is, it has done again, so let's see how the python how the pytoch execution graph will look like. So here if we see, we have run it again. So here our the category is Portuguese, the line or the input is Delgado. We have a tensor which is 8, which means in the category alt category tensor, the output is 8. It should, the final output should be 8, and the line tensor is obviously, because it's a 7 word, 7 1 and 57. So now let's run it once. So if we see, so here we'll have the 7, just a second. So now here if we see, we have 0 1 2 3. So let's also see what does it mean. So here I have created a, so how it works is, we have defined 2 layers. One is input layer, one is an output layer. We are passing the input and the hidden, which gets combined, which gets concatenate, and we get and it's passed to both input and the hidden layer, uh, uh, input to hidden and input to output, and that's how it's been named as well, that So we, from this we are getting a hidden layer. Hidden output is, we call the hidden, and here we call the output as an output. Then we are passing this hidden output as this hidden one, and then input one will be, so here in this case, so initially we'll first pass D with the hidden 0, then E with the hidden input with the hidden as the output of this value, and that's how it will go at the end. So at the end we'll have the output N, and on that we'll run our loss criteria, and we'll pass this category tensor, which is 8, and we'll try it. Then whatever the loss value is, we'll try do the backward propagation. And to see what is the current how this is looking like is, if we go, if we see if we add hidden 0, so not hidden 0, let's add the output 0, so that's what we are interested in. And then we add output 1, then we add output 2, and so here if you see out initially, because we are not tracking so if we see, we are not tracking hidden 0, so it's not part of the execution graph. So the output 0, this is output, actually this is output 1, this here it's showing that if we run dot backward, what will happen is, here we have softmax, then inside this is part of the linear layer, which is doing addition and matrix multiplication and the transpose backward. Then when we are running it second time, then we are running it D on E. So what's happened now is, if we do the backpropagation here, if we do the output 2 dot backpropagation, what will happen is, here in this layer it's doing log, at the end it's doing log softmax, and then addition plus by addition of the bias, and the matrix multiplication of this, and adding both of these terms. This is for I2O layer, and then this is for the hidden layer, which is, I'm doing that here I'm doing the, now it's tracking it, because this is a new linear layer, and its parameters will be tracked for backpropagation. So there I am passing input 1 and the hidden 1. So here it will start doing, we are doing the addition and the multiplication, which is for this layer. So now if we run it third time, it will showing the backpropagation again. This is again, here we are discarding this output for now, because we are doing the classification, so we are interested in the final output. So here we are getting the final output. We are doing the if we do it at the end time, it will be just that we are doing the softmax here, and computation for this layer, and then the whole computations for this I2H. So for I2O we are only getting, so we can even skip, I feel we can even skip running I2H till the end, because it won't matter much. So yeah, again the same thing, it just concatenation, then we are, it's kind of, if we see, this is recurrence, so that's why it's called RNN. Here we are doing the same recurrence again and again. If we run it once more, if we do it once more, if we do it once more, now it has stopped. So it executed till 6, because 0 to 6, because it's a 6-7 letter character. So if we see this one, you see so it was till 2 here. Let's see, here we are 3, so 0, 1, 2, 0 1 2 3 4. So I think we'll see 6 later on. So if we 0 is clear, 1 is clear, 2 and then 3. Yeah. And then here if we add our yeah. Yeah, so here if you see output 0 we discussed, output 1 we discussed, output 2 is again output 3 and output 4. As we can see, output here we are using only at the end, we are discarding the rest, but the input layer we are passing it to uh, every time we are processing, and I think that's why it's called recurrent. If you see, the same blocks are getting called again and again. And so if where we were, so if I close, yeah. So now if I'm calculating the loss, yeah, so here we can see that once we run, so here we finally calculated the loss, which is the criterion, and if we see the graph, it's showing that this is our current graph, it's a loss backward, and then this is the last output layer, and these are the recurrent input layers. And now if I will run loss.backward, it will calculate the gradients based on this execution graph. And now we should have the data in the p.grad. Let's see if we run it. So what is p dot, and we have name. Okay. So I think, as we can see, this is for the first input layer. So here we can also do if we do the parameters, it has क्या हो रहा है नहीं Yeah, so as we can see here, R&R parameters are basically tensors. Uh, they appear inside model parameters. This comes handy when we build custom modules, which we have built right now. So anything which is true for Python tensors is true for parameters, is they are tensors only. So as we can see here, one of the interesting properties is that so an interesting property is that I am doing R&R parameters, which means that what they are saying is, so they have been added to R&R parameters. So what are these parameters? If I see our model was here, we have added self dot I2 h self dot I2o. So only these parameters it's considering. If we added another parameter, we have added a basic tensor, it wouldn't have been shown in the parameters list, because as they are saying, we can add a few parameters, we can add few tensors just to store some caching or something else. So there we may not need the gradient descent. So here as they are saying, if you do a gradient descent, it will update only the registered parameters of the model. Cool. So which means that if I have manually defined some tensors here, it won't update those. Okay, so the interesting thing is, what they are saying is, so when we are defining this RN is an RM module, right? So which means that it will have a parameter functions which will return all the trainable parameters for this module. And the beauty is, if you add so if you add yeah, so what it's saying is, here what we did was we assigned a member of this class to this. So what it does is, it also adds all the parameters of this layer to this parameters. It's called registering parameters of modules. So now what they also say is that if you add a tensor, it won't work because you have not defined it as an NN parameter object. And the reason is, so if you want to define some tensors which are non-differentiable, so for that they have facilitated so that it doesn't calculate, it doesn't do any gradient on. Yeah. So if I do, so here it's showing me 4, which is 2 bias and 2 weights for these 2 layers. And log softmax doesn't have any parameters to train, that's why it's only have for these 2 layers. Yeah, so here finally what we are doing is, P is a sort of tensor, we are in data, and then we are doing add, and we are adding the grad to that. and I'm saying alpha is which we use to scale this value, which is this value. So it's actually, it will become learning rate into this minus value, and we will be adding that. Not sure why they added, they have used this instead of directly using the add, which we'll see later on. Yeah, so here then we are done with the first iteration, or we have done, here we have now have we have trained our neural network using the first training set, and we are returning the output and the loss value for tracking purposes. And now if we pick another item, if we see in the terminal, it has picked another item, and we'll do the same thing again.